Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to look at the factorial and permutations. Let's go to the chalkboard and get started. Today, factorials and permutations. Factorials and permutations. So, in order to start today, we're going to, let's imagine this. Imagine, or suppose, I like imagine, be creative. Imagine you have a bookshelf that holds your favorite 7 books. Your favorite 7 books. Okay? And let's try to imagine this. Let's see, we're gonna have a collection of books on the shelf. Who knows what those books might be? They probably look something like this. And I'll probably come back in here. Like for example, I've asked classes before, and it seems that a very common book that we tend to have is Harry Potter. So let's write Harry. We'll write Harry here. And then let's see, we have another book. Maybe it's a pink colored book. Let's give it another color. It'll help us to see this as well as we progress. Actually, I'm going to draw my book this way here. So there's my first book. This is Harry Potter. Okay. And now maybe we have another book. Maybe it's a pink book. Well, this pink book, what book could that be? Now oh well, my students used to tell me that Shades of Grey was one that I should have on my bookshelf. So I started listening on tape, and I didn't get very far. It wasn't my style of book, but maybe you do have Shades of Grey on your shelf. Let's see, what are some other books that you might have? Oh, goodness gracious, if you're watching this video, I would assume then that you have a, probably, maybe even inarguably, your favorite book of all is your math book, right? That's why we're all here, so we have a math book. Oops. Math. Maybe even just statistics. Maybe this is the one book that has all math in it. Math and Harry. People used to have dictionaries, but those have kind of all gone online. But if you've ever had one, they're fun to actually flip through the pages. So maybe in your collection you had a dictionary. For which you studied diction. I'll have to abbreviate it. And then, let's see, what else would you have had? Maybe you had a blue book. Sure, maybe it was just blue, because there was. Maybe the content in it was said, made you feel blue? So it was your blue book. So let's call it The Story of Blue. Oh my goodness. That reminds me of another book that I would think there's 5. Another book that you might have in here, just for the namesake alone, it was also made into a movie, was The Story of Pi. I just liked the pie part, it caught my attention, but it was a wonderful story. Oh my. And then maybe your last book, well, I don't know what your last book might be. I'll let you put your own name here for your book. Call it the question mark book. Okay, so there's our library. And the question to you here is, how many ways can you organize your library? So let's write that. We'll put it right here. We'll put it over here. I think there's a little bit more space. The question here today is, how many ways can the books be arranged on the shelf? On the shelf. And that's a question. And that's what most of our counting questions are going to be. So there's my bookshelf. And notice that it's not really which books are in your library. It's the fact that you only have room for 7 books. So I think that a great way to start many problems, if you can, is to draw a picture. And it doesn't have to be a difficult picture, and it doesn't have to be all the different ways you could organize these books, with colors and everything. All it has to do is represent the spots on the bookshelf. It's a very simple picture. So let's draw that. Let's draw our bookshelf. So our bookshelf really is just positions. There's the first spot on the shelf, second spot, third, fourth, fifth, sixth, and seventh position. So that's what these lines represent. They represent the positions on the bookshelf. Okay, so let's think about this. So maybe you find that you love your books so much that each week you decide you're going to put them in a different order. How many weeks would it take? How many weeks would it take for you to order it or go through all possible arrangements of your book? Well, let's think about this. When I look at my library, there's 7 different books that could go in that first spot. So let's put down a 7. Now, remember when we were drawing a tree, our first branch of this tree would now have 7 books. Each one of these represents a branch. But now, let's just say that for simplicity, we put Harry in the first spot. So I'm going to just put an X. So now if I put Harry in the first spot, then that means from each one of those branches, I could put 1, 2, 3, 4, 5, 6 more options on the end of each one of the first 7 branches. But you don't have to draw that tree. Remember, the multiplication rule says that all you have to do is just record the number of possibilities for that second branch, 6. So let's say we put blue in the second position. Now we go to put another book on the shelf. So we have to ask ourselves, how many books can go into the third position? Well, we have 1, 2, 3, we've used blue, 3, 4, 5. We have 5 books that could go into the next position. 7, 6, 5. Oh, this is always a tough one for me. I'm going to put pi. I'm going to put pi in that next position. The story of pi. But now let's see. Now I need to choose another book. I have 1, 2, 3, 4. I have 4 books that can go into the next position. All right. Maybe we put math. Math went into the 4th position. So then now we have 1, we have gray, we have the dictionary, and the question book. That's 3. That's 3 different books that could go into this next position. I think you are probably seeing the pattern now, but let's just finish it. We've gone so far. Let's put the question in that 4th, 5th position. In the 6th position, maybe let's put the dictionary. So, but when we go to put the next spot, there's either gray or dictionary. So there's 2 books available. 2 books available. Let's place dictionary. And now I have only 1 book. I have gray. Gray in that last position. There. Now, the multiplication rule says we multiply those out. So this is 7 times 6 times 5 times 4 times 3 times 2 times 1. And it equals, okay, this is a big one. Let's try this together. If you have a calculator, please check. We get 6 here. 6 times 4 is 24 times 5 for 120. Ooh, 120 times 6. Well, that's going to be 6 plus 100 plus another one. 720. Okay, 720 times 7. That's going to be 4,900 plus another 140. I think this is 5,040, and you should double check. Now, I write this down because it's nice to see, it's nice to get the answer. But there's actually more to the point of this. This pattern of descending multiplication, 7 times 6 times 5 times 4 times 3 times 2 times 1, and it stops at the 1. Because, now think about this, if there was a 0 right here, well, 0 times any number is 0. So there's never a 0. There's never a 0. When we have this pattern, we always stop it at 1. And instead of writing all that, we can also write that as 7 followed by an exclamation point. And that is read as 7 factorial. And 7 factorial. Okay? There's something interesting though. What happens if there was a 0? And actually it's already defined, and we will see it in the next couple of videos. That there's one thing you need to note, and this is defined, so I'm going to give this to you. Define 0 factorial, and you should check this. You should check this in your calculator. 0 factorial equals 1. Okay, so you will need that. 0 factorial is equal to 1. And in general, we would say that n, so in general, we say that n factorial is equal to the first number n times n minus 1 times n minus 2 times, and you just keep going all the way down, subtracting 1 until you get to only 1. And that's it. That's n factorial. And you can see when n was 7, the 6 is 7 minus 1, 7 minus 2, then there'd be 7 minus 3, 7 minus 4, 7 minus 5, 7 minus 6, which is 1, and you're done. Okay, that's the factorial. Now let's add a piece. Thank you for waiting. Here we are. The next piece we have to do, and it's almost tragic. We have to move. It happens in life. Sometimes you have to move. And here's what's going to happen to you. You move. You have to move. You have to move. So, of course, you take your 7 prized books. However, here's the catch. However, your new place, has a bookshelf. That only holds 4. You write that. Those are grammar minded. 4 books. Okay? Just to clear this, I know some of you are like, well, why didn't I just take my bookshelf with me? And the answer is run with this here. There's plenty more to learn than how to pack bookshelves. Maybe it was a built-in bookshelf. Only holds 4 books. And the question remains the same. How many ways can the books be arranged on the shelf? On the shelf. Okay, that's the question. Let's try this. I always find, where to start? I know. You know where we should start? Let's start with a picture. And it doesn't have to be this picture over here. It doesn't have to be our first picture. It can very simply, I realize I probably just walked off the screen. It doesn't have to be our first picture. It can be this simple picture. This is our new bookshelf. So our new bookshelf looks like this. It has 1, 2, 3, 4 slots. Now, but you have 7 books. You have 7 books. So you're like, all right, which book would go in the first spot? Well, you have 7 to choose from. So let's do this. Sometimes, I'm going to grab some colors here for a moment. I may not need to necessarily recreate the whole library, but sometimes if you get stuck, maybe just think of 1, 2, 3. You could use different colors if it helps. 4, lots of different colors. 5, you could use different shapes if that helps. 6, and 7. Those just could be, these are your books. So let's try that. Initially, we have 7 books to choose from. We put one up. So now, Now how many books can go into that next position here? I have 1, 2, 3, 4, I have 5, and 6. So there's 6 books that could go in the next slot. So let's scratch another one. So now I have 1, 2, 3, 4, 5. I pick one. Maybe I pick this green one, put it in there. But now how many books? 1, 2, 3, 4. There's 4 books that I could put into that last spot. I multiply as we've come to learn. Now, here's the problem. I'm not going to jump to the answer. You may have already done that. Well, you know what? If you just want the answer, I will give that to you. Let's do this together. 5 and 4, that's a 20. 20 times 6 is 120. 7 times 120, that's going to be 840, I think. If it's not, that's okay. You correct it. You have the calculators, but I think that looks right. 7 times 20, yeah, 840. No? 700 plus 1. Yeah, okay, I think that's right. But this isn't my big concern. My big concern is this. Now, I can't speak for you, but I can tell you that when I started writing this 7 times 6 times 5 times 4, what I really wanted to do is just keep writing. So let's do that. I really wanted to write this. I really wanted to write 7 times, 6 times, 5 times, 4 times, 3 times, 2 times, 1. But that would have been wrong. But look at this. What if, because I don't need the 3, I don't need the 2, and I don't need the 1. So what if I wrote 3 times, 2 times, 1? These all cancel with those. So it's still 7 times 6 times 5 times 4, but look at how nicely this works out. This is the same as 7 factorial over 3 factorial. Now you might think, wow, that's really slick. I mean, that's what I think. But the question says, notice we have a 3, but there was never any mention of 3 in our original problem. There was 7 total, 4 slots. 7 total, 4 slots. Where did that 3 come from? That 3 comes from, you have 7 total objects, of which you need 4. So that's going to leave 3 unused. And that's where the 3 comes from. And not only that, but this notation is also often written as 7p4. And what it means is 7 objects. Okay, for those of you that are good at English grammar, I should never start a sentence with a letter or a number. So 7, this says 7 objects. 7 objects permuted permuted 4 ways. Oops. 4 ways. That's what this means. So when the factorial needs to be stopped, we use a permutation. When the factorial needs to be stopped, we use the permutation. And at this point, there is a note I would always concern. And that is, I think personally, drawing this picture in more cases than not is a much more infallible way to get to the answer. I think understanding the permutation notation and how I'm going to use it takes more practice. So when you're working on problems, I would encourage you to try both. Write it this way and then recognize the wording that's also could be written as a permutation. So practice both ways, practice with an awareness of that. Then Oh yes, in general, so let's do this. In general, let's do this. N objects arranged R waves is N P R, and it's N factorial divided by N minus R factorial. And that is a permutation. Thanks for watching.